Very good morning to everyone. In this lecture, EC8791 Embedded and Real-Time Systems. In previous session, we are discussing the EC8791 Embedded and Real-Time System Unit 3, that is the embedded programming. And what are the different type of models of programming we are using in the embedded system design process, and what are the basic individual steps in how to the data can be used to integrate the programming level. So what are the methods, that is assembling method or linking or loading method, we have followed the different locations. Now today we are going to discuss the program level performance analysis. The program level performance analysis, it is a technique we use to analyze the program execution time and are also helpful in analyzing the properties such as power consumption. The CPU execute the interior program at the rate of we are desired. So the program performance measurement, it is a important things, that is we are finalize the solution for each individual executed operations. So the execution time of the program often varies with the input data value. The catch has a major effect on program performance and catch behavior depending in the part of the data values into the program. Then the execution time of an instruction in a pipeline depends not only the instruction but on the instruction around in the pipeline method. So we can see this the level of performance analysis in the execution time, that is the total execution time of a program, it is a varying the input data value. So we can measure the program performance. So the measurement we have to different category, that is first one is a simulator. It is a primary simulation of each individual data operation, that is a compilation, and also the program is a loading and linking operations are needed. So the simulator, it is runs on a PC. It take as input and executable for the microprocessor along with the input data and simulate the program. Next the performance analysis technique, timer. The timer is used to measure the performance of executing the sessions or section of code. So the we have to take the example of our different high level modules. That is, we are, for example, for we are merging the different type of flip flop in the transistor design models. It is one of the VLSI design application. So we want to merging the flip flop. So we have to find out the output of the power analysis, power reduction analysis techniques. So the flip flop can be connected with the synchronous time period. So the clock time of the session in one flip flop produce the output to the another flip flop input. It is a combination of two merging the registers. So we can simulate the flip flop modules, and also we can analyze the timing performance. That is an important role in the program performance measuring technique. So the length of the program that can be measured is limited by the timer, accurate of the timer. Now the logic analyzer to measure the start and stop time of the code segment. The length of the code that can be measured is limited by the size of the logical analysis buffer. So the performance parameter can be divided into different category. There is a average case execution time and also worst case execution time and best case of execution time. The average case execution time, it is a typical execution time. We would expect the typical data. And then the worst case execution time, it is a longest time that the program can spend on any input sequence is clearly important for system that must meet the deadline. It is a worst case execution. It is based upon the timing levels. Next, best case execution time. It is a important in multi-rate real-time system operations. It is a goal of the embedded system design technology. So, the program level performance analysis we are going to discuss to optimize the level of to reduce the worst case execution and also the average case of execution time period. So the performance analysis or measurement in the compilation, that is a simulation part, and also the timing and also the logical analysis. So the three different category we have to optimize the programming level, and then we are implemented through the hardware to produce a good output. So what are the elements of program performance? So the program performance parameters are there, that is average and worst and best. What are the program performance elements? It is our execution timing and program path and instruction timing, etc. So the execution timing, the execution timing is nothing but the program path plus instruction timing. So how do we write the program? How do we are using the instructions? How do we optimize the length of instruction to reduce the techniques? For example, we are the VLSI design technique, we are using the pause transistor logic to eliminate the transistor level counting. So those kind of examples we are needed in VLSI design technology. The same technology, the same programming level optimization technology we are usually in the embedded system design. It is a performance analysis or performance improved technique. Next, the instruction timing performance. It is one of the element of programming performance. It is based on the sequence of instructions traced by the program path, and also that not all the instruction it take the same amount of time. That is I am telling the flip flop, merging flip flop in same synchronous time period. So the execution of an instruction may depends upon the operand values, what type of operand we are using. Then the measurement driven performance analysis. To measure the program performance, we need the CPU or its simulator. The measuring program performance, it is a combination of determination of the execution path and the timing of the path. So the program can be traced and it record the execution path of the program. It is it is most suitable for the program performance analysis. And then the cyclic accurate simulator, it is used to design or determine the exact number of the clock cycles required for the execution. It is a build with the detailed knowledge of how the processor work. It is a slower than the processor itself, but a variety of techniques we can be used to make the best case of execution time period. Next, we have to complete the module of the processor, including the cache memory system, and it can be provide the information about why the program run too slowly or why the program are executed slowly. So in this session, we are discuss the program level performance analysis in embedded system design technology. Thank you for watching this video.